Section 3.5, parallel lines and triangles. Postulate 3.2, parallel postulate, states that through a point not on a line, there is one and only one line parallel to a given line. So no matter where you draw a point in space, there is only one line that can be drawn through that line that will be parallel to another given line. Theorem 3.11, triangle angle sum theorem. The sum of the measures of the angles of a triangle is 180. So if you add up all the angles of your triangle, they should equal 180. If they do not, they are not a triangle. An auxiliary line is a line that you can add to a diagram to help explain relationships and proofs. Here we have the proof of Theorem 3.11. They've given us that we have triangle ABC, and we've been asked to prove that angle A, angle 2, and angle C equal 180. So we're trying to prove that the angles of the triangle add up to be 180. So for this proof, they're drawing a auxiliary line to start off with, which is your auxiliary line or parallel postulate. Then they start talking about your supplementary angles because we have linear pair, so PBC and angle 3. Then they know that if they are supplementary or a linear pair, they add up to be 180. That's just definition of supplementary. Then they know that PBC is the sum of 1 and 2, so that's angle addition. Then when you take angle 1, 2, and 3, you should get 180. Well, all they've done is taken angles 1 and 2 and plugged them in for PBC, so that's substitution. Then they know that angle 1 and angle A are congruent, and angle 3 and angle C are congruent by the alternate interior angles theorem. They've changed from congruence to equality or distance, so that's definition of congruence. And then last but not least, they substituted A and C in for 1 and 3 to prove the proof statement through substitution. Here we want to find the measures of x, y, and z. So remember that the angles of a triangle add up to 180. So to find x, we would take 180 minus the other two angles. So 180 minus 32 minus 46. So in this case, x should equal 102. If we know that x is 102, to find y, we're going to recognize that they're a linear pair. So we'll take 180 minus 102, and in this case, y should equal 78. And then z, same way we found x, we'll take 180 minus the two angles we know, so y, which is 78, and the 36, and we should get the angle z is 66 degrees. Theorem 3.12, triangle exterior angle theorem, states that the measure of exterior angles of a triangle, or the measure of an exterior angle of a triangle, is equal to the sum of its two remote interior angles. So in this case, angle 1 is exterior, and it equals the sum of 2 and 3, or the two angles on the far end of the triangle inside. An exterior angle is formed by a side and an extension of an adjacent side. In this example, angle 1 is an exterior angle. Remote interior angles are in relationship to your exterior angle. They are the two non-adjacent interior angles. In this case, 2 and 3 would be examples of remote interior angles. They're the two angles not beside your exterior angle inside the triangle. Question 1, what is the sum of the measure of angle 1? Well, this is our exterior angle. So the sum of that angle, or the measure of that angle, should be equal to the sum of the two interior angles, or the remote interior angles. So the measure of angle 1 should equal 46 plus 41. So the measure of angle 1 is 87 degrees. For question 2, what is the measure of angle 2? Well, we have our exterior angle and we're looking for one of our remote interior angles. So what we can do is we can say that 119 equals the measure of angle 2 plus 53. To solve this, we'll just subtract 53 from both sides. And in this case, we get the measure of angle 2 to equal 66 degrees. Question 3, what is the measure of x, y, and z? Well, in this case, we can start by finding angle x the same way we found the previous example. We know that 130, the exterior angle, is equal to x plus 63. So we'll subtract 63, and we should get x to equal 67. Y and this angle here are vertical, so that means y is automatically 63 because they're congruent. And then to find z, we know that a triangle adds up to 180. So we'll take 180 minus 63 minus 85. And in this case, z should equal 32. The measure of the exterior angle of a triangle is 110. The measure of the remote interior angles is in a ratio of 2 to 3. So 110 is the exterior angle, but they tell us the ratio of the other two angles is 2 to 3. So what we do is we just tack the variable onto each of these numbers. So in reality, one angle is 2x, the other angle is 3x. And so now we're just going to solve this. So combine like terms. We've got 5x equals 110. And that means you divide by 5, and x should be 22. Then to find the measure of your two angles, you just merely plug them back into their ratio. So 2 times 22 gives us the measure of angle 1 is 44 degrees. 3 times 22 gives us the measure of angle 2, 66 degrees. So here we have 3 angles of a triangle. We know that they should add up to be 180, so we're going to add them up and set equal to 180 to find the measures of the missing angles. So x plus 2 plus 6x plus 10 equals 180. We'll combine like terms. We end up with 8x plus 12 equals 180. The idea here would be to subtract 12. We get 8x equals 168. So we have 8x equals 168. We will go ahead and divide by 8 on both sides. And we're going to get x to equal 21. Now to find the measure of the missing angles, we just plug it back in. So this angle here, 21. This one is 23. And here, we've got 6 times 21 plus 10 gives us 136.